All right, so we want to do the entire curve sketching algorithm for this problem over here. So the first thing I'm going to do is find my x-intercept and my y-intercept. So to find my x-intercept, it's just the solution to the numerator of this equation, which is just going to be -3. And to find the y-intercept, I'm going to sub in x as 0 and solve it. So I'm just going to have +3 over -4, which is just -3 over 4. The next thing I'm going to do is find my vertical and horizontal asymptotes. To find my vertical asymptotes, I need to factor the denominator. That's going to be by difference of squares, so x plus 2 times x minus 2. So my vertical asymptotes are just the solutions to my denominator, which are +2 and -2. And for my horizontal asymptote, I know the degree of the top is greater than the degree of the bottom, which means that you have a horizontal asymptote of y equals 0. The next thing I want to do is I want to figure out my critical points. In order to find my critical points, I need to derive this function, and we're going to use the quotient rule to derive this function. F equals x plus 3, g equals to x squared minus 4, f prime equals 1, g prime equals 2x. And now I'm going to do quotient rule. So f prime g minus g prime f divided by g squared. I will simplify the top over here. So this is just x squared minus 4. This is going to become negative 2x squared minus 6x. Denominator stays the same. You don't need to simplify that. Then I'll combine like terms in the top. So I have negative x squared minus 6x minus 4 over x squared minus 4 squared. So this is my simplified form of my derivation. I'm going to make it equal to 0 now and solve to find my critical points. So if I make this equal to 0, I can cross multiply this. So I just have 0 equals negative x squared minus 6x minus 4. And then to simplify it a bit, I'll just divide everything by -1. I like having positives much better. And if they're all negatives, I just divide everything by -1, switch it to all positives. Now this can't be factored as a simple trinomial, so we have to use quadratic formula over here. So x equals negative b plus or minus root of b squared minus 4 times a times c divided by 2 times a. Then I'll put this in my calculator. I'll get my 2 decimal solutions for my critical points. My first one is negative 0.76. And my second one is negative 5.24. Once I get my critical points, I want to do my number line next. So I'll do that all the way up over here. I have a number line. On my number line, I want to put all my critical points and my vertical asymptotes. So these two and these two. I'm going to start with the lowest, which is negative 5.24. Then I'm going to go to -2. Then I'm going to go to negative 0.76. And then the last one I'm going to test is +2. Remember, these two are critical points. These two are vertical asymptotes. Now I want to test each range to see whether it's going to be increasing or decreasing. I'm going to start by subbing in -6 into my derived equation over here. So if I sub in -6 into this derived equation, so f prime of -6 is a negative number. So since it's a negative number, it means that the graph is decreasing in this range. So negative means decreasing, positive means increasing. Next, I'll sub in a value between these two, which is -3. And if I sub in -3, I get a positive value. So that means this is increasing over here. Next, I'll sub in a value between these two. I'll sub in -1. I get a positive value again, which means it's increasing again. But this is an asymptote, so don't have to worry about that. And then I'll sub in 0 for this. Actually, I'll sub in +1. If I sub in +1, I will get a negative value, and negative means we're decreasing. And then last, I'll sub in f of 3 here. If I sub in f of 3, I'll get a negative value, which means I'm decreasing again. That's what it looks like over here. So my intervals of increase are from -5.24 till -2, and then -2 to -0.76. I have two intervals of increase. My intervals of decrease, the first one is right there from -infinity till -5.24. The second one is -0.76 to +2, and then the third one is +2 to +infinity. So 3 intervals of decrease. Once I finish these, I want to classify these 2 points as maxes and mins. As you can see here, this is clearly a minimum. So I have a minimum, and it's at -5.24 as the x value. In order to find the y value, I will sub this into the original equation. So if I do that, I will get -0.1 approximately. If you want to take more decimal places, you can, but to 2 decimal places, it rounds to -0.1. So that's my minimum. My max is this one over here, because as you can see, if you connect these, it's clearly a max. It's -0.76 x value. And if I sub this into my calculator in the original equation, I will get -0.66 approximately. So now I've found my minimums and maximums. I've completed my intervals of increase and decrease. Now I need to go on to my second derivation. So I'm going to derive this function a second time. You're going to use quotient rule again. So f equals -x squared minus 6x minus 4. G equals x squared minus 4 squared. F prime equals -2x minus 6. G prime equals 2x squared minus 4 times 2x, which is just 4x times x squared minus 4. I'll do quotient rule. So f double prime of x equals negative 2x minus 6 f prime times g minus g prime times f. I'm going to squeeze that in down here because it's on no space. That's what it looks like. And this is all divided by g squared. So x squared minus 4. And now the new exponent is going to become 4 because squared becomes 4. The next thing I'm going to do is I'm going to divide all three terms by x squared minus 4. That's going to simplify it a lot for me. So here I cancel out this x squared minus 4. Here I cancel out the square. And here this 4 becomes a cube. Let me write it a bit more neat on the next line. So I have negative 2x minus 6 times x squared minus 4 minus 4x times negative x squared minus 6x minus 4. And this is all divided by x squared minus 4 cubed. Grab another cube to continue. So I'm going to expand out the top now with FOIL. It's my next step. So this is going to become negative 2x cubed minus, actually plus 8x minus 6x squared plus 24. And this, when I expand it, is going to become plus 4x cubed plus 24x squared plus 16x. Again, it's all divided by x squared minus 4 cubed. Now we can combine like terms over here. So that's just 2x cubed negative 6x plus 18x squared plus 24x oh no, plus 10x. Oh, 24x actually, that's correct. Plus 24 divided by x squared minus 4 cubed. Okay, so we need to factor this out now. We also know that this is our most simplified equation for our second derivation. So I'm going to make this equal to 0 now to solve for inflection points. So the denominator is just going to disappear. It's just going to multiply with 0. So I'm just going to be left with the numerator. And then we just have to figure out whether we can factor this or not, which is pretty difficult. I'll start by dividing everything by 2. And then you want to do factor theorem over here to see whether you can basically get a solution for some kind of inflection point. So we know that no positive number is going to work here. No positive number is ever going to equal to 0 because these are all pluses, which means the only possibilities are some negative numbers. So you want to test a couple of negative numbers in this. I'll start with negative 1. I get positive 8, which is not a perfect factor. Then you can try negative 2. Negative 2 doesn't work either because it gives me 16. I'll try negative 3 next. Negative 3 does not work either. And then I'll try negative 4. -4 does not work either. So the last number I have to try is -6. Remember, you just have to try multiples of this number over here. I did 1, 2, 3, 4, and I'll do 6. 6 doesn't work either. It's very unlikely to be 12 either. You can test for 12, but I'm pretty sure that doesn't work either. So that means there's actually no inflection points here. Since we have no inflection points, the only things that go on our number line are the two vertical asymptotes, which are -2 and +2. I'm going to pick a value over here and sub it into this second derived equation. I'll pick -3. If I sub it -3 into this equation over here, I will get a positive number, which means that this is concave up. Let me double check that really quick. Yep, you get a positive number here. Over here, you're going to get a negative number, meaning it's concave down. And for the last range, you're going to get a positive number, it's concave up. This just means that intervals of concave up are from -infinity to -2, and from +2 to +infinity. Now, intervals of concave down are just from -2 to +2. There's no inflection points here, so we don't need to find it. So now we have all the information we need to sketch this function out. Let me start with doing my X and Y axis. I'll then put my vertical asymptotes. Next, I'll put my horizontal asymptote, which is just at y equals 0. Remember, this only acts for the end behaviors, not for the middle of the graph. Then let's put our x-intercept, which is -3. Our y-intercept is -3/4. Our maximum and minimum. So our minimum is at -5.24 and -0.1. So it's like really close to the axis, but I'll make it a bit further just so that it's a bit clearer. This point is -5.24, comma, -0.1. Our maximum is at -0.76 and -0.66. So this, I have to move this point a lot lower, because if that's -0.1, the y-intercept of, what is my y-intercept? -3/4 will be a bit below this. So I'm gonna move my y-intercept there. Basically -3/4, which is -0.75, but I've expanded the scale a lot in this graph for this point. So my maximum is over here, which is negative, again, this is approximate, this drawing, -0.76, comma, -0.66. That's my maximum right there. And I have no other points that I can draw. So now I can use my intervals of increase and decrease. But the easy thing to draw is this part right here. I know this is a maximum, so it has to go like this. There's no other possibility for the graph over there. So that's very easy to draw. I know this is a minimum, but I also have a horizontal asymptote here. So this is going to look like this, and then it's gonna come up over here, and then it's gonna look like this. There actually is an inflection point somewhere over here. There has to be an inflection point because it's changing concavity, but it's very hard to determine this inflection point from this cubic equation over here because it's very hard to actually factor and get the right value. But I can put in Desmos really quick and see whether my inflection point is a whole number or not. Nope, it's a very hard fraction and it's pretty much impossible for you to solve this without a graphical calculator or doing some kind of advanced math. So you don't need to find inflection point in the question this difficult, but it definitely exists. There's an inflection point that exists over here, and the x value is basically negative 7.6. But again, don't need to worry about finding that. You will never be required to find this on a test. And now finally, we gotta come to the last side here and we gotta draw it. So there's only two possibilities for this side over here. Either it's above or below. So we know that it's concave up. Because it's concave up, it has to be above. Because this is the only way the graph can be concave up on this side. We also know it's decreasing. That's an interval of decrease from 2 to infinity. So both of them correlate with like that. If it was increasing and concave down, it would be below. And that's how you would draw the graph for this problem.